Yeah. So what we said is that the machine learning thrives on data. Without data, nothing can be done about it. So the data that we have, that data, depending on what model you want to do or develop for whatever specific application. If you recall, when we started, we told you that there are two types of machine learning models that are developed. One is what we call supervised learning, and then the other one is unsupervised learning. And there are others that are in between. Right. But the two broad ones are supervised and unsupervised learning. Now, the methods or the algorithms that are used to do this varies. So we'll be going through the algorithm as we go along. So if you look at the outline, we have shared certain things that will be done. So whatever you want to develop, you need data. And that data for the supervised learning, then whatever information you provide, you have to provide if you call the expected answer. So when you have this large data, this data, you didn't generate that data. That data will be actual data. Let me repeat, actual data. We'll share, so as we start, we'll be sharing some sources of data with you for some of the things we'll be dealing with. Now, so this actual data that you have, the data may come in different forms. You may have data that may come with yes or no, maybe a survey trying to find out whether students like a particular food, yes or no. So you collect samples of maybe 500 responses from students. So you see that this data that you have, it doesn't have any value. It's just yes or no. So how do we deal with such a situation? Because for us of now, we have taken you through a certain number of things, and we've seen that we deal with numbers in order to do this calculation. So how do we deal with such a situation? You may also have a situation where even in the yes or no, some students will say, I don't have any answer. So it will be blank. How do you deal with such situation? You may also have situations where instead of yes, a no has been provided. So the data that we have may have different information content or different format and things like that. So how do we first, even how much data size do we need even to develop a model? And then two, how do we process this data so that we'll put it into the right form that we need? We put it in the right form or format in which we need in order to go through with our model development. So the data that we have, there are two types of data. As I said, one is one that is the actual data. That one, we have it physically. It will be given to us, or we go and look for it. Then another type of data will tell you, okay, the data we have, we don't have it. A typical example is some of the projects that we work with Korle Bu. I've been working on a number of projects with Korle Bu. Now, some instances, they will tell you, okay, please, if you come and mute yourself, otherwise I'll be forced to mute everybody. Right. So the key point here is now we're working with consultants at Korle Bu. They tell you, okay, we don't have readily available data. And you want to come up with a machine learning model that could be used to diagnose certain conditions in the hospital. They tell you we don't have. So without that data, you can't do anything. So what do we do? So we have something we generate the data, which we call synthetic data. But we don't just get out and generate the data. But what we do is we sit down with the medical doctors and then, or whichever solution you want to develop, then they will walk you through the process. Okay, we do this, we expect this. So all that they will be telling you, then you'll be putting it into context. And out of that, you generate your data. How many variables that are involved, then what are the types of the variables? So you use all these things in order to generate that data. But the data must also be in a situation that should not be skewed towards a particular, because real life, we don't have everything perfect. So we just started last week. We started with you on the processes involved. We are going to continue until we get to the level that we think we have now fully processed the data. Ken, please, do you have a diagram, a typical diagram of the data processing procedure?
Sir, no. I'll get that next week.
Okay. Maybe I'll prepare something. I have some of the work that we have that can just trust some of them. So I will then hand over to you so that we continue from where we left off. And then if we need it, I think we can also introduce them to the Kaggle data set to get a feel of how the data looks like. They have different applications.
Sure.
Okay, so you can please take over and then I'll come in as and when they need arrive.
Okay, thank you very much and good morning once again to everyone. So we are going to continue from where we left off last week. We started with our data, getting to understand data, doing some pre-processing. Today we are going to take it a notch higher and make progress. So I'm going to share my screen with you. Okay, so once again, we are going to grab a template of which we are going to use today. So like I always do, I'm going to show you the process and then I will share the link with you, the repository link, so that you can grab the template and also work with it. Okay, so we are looking for pandas, this one. So once again, I'll click on download and then we are going to download the zip file. So once this is downloaded, let me quickly do the extraction. Let me put this on my desktop. Okay, so here is it. I'll open it and then, yep. So when you do the download and the extraction, we are definitely going to have these files. So like we always do, we'll come inside of this and type in CMD and press enter. Now, the reason why I'm doing it this way is to make things very simple for you, okay? Now, there are several ways of opening up your Jupyter Notebook environment and stuff like that, but I feel there's a very simple way to go about it. Now, you could have typed in, just open your command prompt this way, and there is going to be a little bit of a problem if you're not very comfortable working in this environment, because your default location is going to be like your computer, okay, your C drive. That's what you see over here. So I'll do ls. In fact, this one is not even showing me. So I can do cd to desktop. Now, clearly you can see that the path has changed from just Lenovo to now I have desktop over here. Then inside of desktop, I want to go into this pandas-master folder. So I'll do this and I'll do cd. cd is change directory to pandas dash master folder. So when I press enter now, you could see that that directory has also been added. So that's currently where I am. Okay. Now we are cutting everything short by simply going into the folder ourselves. And then inside of the address bar, type in CMD over here. All that you are trying to say is open the command prompt in this particular file directory. And that's what we see over here. Then I type in Jupyter Notebook to start the Jupyter Notebook server over here. So there's something I went through last week, and I believe you had time to practice over the weekend. So once again, let me just share this with you in the chats, and also I'll put it on the platform so that you can have it. Okay, so this is what we have. We have a number of files over here. So if I'm to go into the pandas templates, sorry. Yeah. If I'm to go into the pandas templates, this is going to open this up for me. Okay. All right. So this is what we are going to work in. And I think the one I have as test, the notebook over here, I believe is the one. Yes. With the examples I did, I think last year or so. Okay. So this is what we are going to use. So we need to understand some few things about pandas. Last week we dealt with NumPy, and we said NumPy was numerical Python. So most of the data, when we are dealing with arrays, we are definitely going to use NumPy. And we saw some of the interesting things we can do with NumPy. Today we are looking at pandas. So the big question once again is, what exactly is pandas? So pandas is a Python library used in data science and data analytics. And since data is going to be something we are going to use in our machine learning model development, definitely we need to kind of learn pandas in a way. So it is more or less a means to the end for us. Now it has functions and methods, just as we saw with NumPy. It has a lot of methods to calculate eigenvalues and all those things that we saw. This one too has its own unique functions and methods that we can use for exploratory data analysis and some data manipulation, some computations, and you are going to see it as we move along. So the big question is, why should we learn pandas? Of course, there are a number of reasons, but then these are few ones. Now, pandas allows data scientists to import, analyze, and explore data. Pandas is used for pre-processing, especially in data cleaning. So sometimes, like Dr. Mills was saying, you may be presented with data, or you might even go onto the field to get data, but along the way, maybe the entry, there was a problem some way, somehow. So you may have some bad data in there. Pandas can help you do the cleaning. And our pandas provides data scientists with some statistical inferences on data. And this is very good. Now, imagine you have about 1 million instances of data, or you are given, the Electoral Commission gives you the over 80 million people who are registered on the electoral register, and says, well, chances are there are some duplicates in there. How do you find the duplicates? You cannot go through each and every entry one by one to keep track. By the time you get to entry number 5 or entry number 100, you probably might have forgotten what you saw in entry number 5. So pandas gives us the opportunity to get some statistical inferences. If there are some outliers in our data sets, we can simply see it based on some understanding that we are going to have moving on. Now, the last point I have over here is it is easy to learn, and you are going to see. So in order to install pandas, once again, we do a pip install pandas. But then we can come in here and go to the official website. So I have the link embedded in this file. So when you click on this link, it takes you to the pandas official website. And you can read a few things about pandas, and they get support from Intel, from NVIDIA, and some big companies and charity organizations who support. So it is something we are definitely going to see if we are definitely going to work with machine learning and data science projects. So In order to install pandas, we do a pip install pandas this way. We can run it over here. Now, those of you using the Mac operating system, you need to do a pip3. So you do pip3 install pandas this way for this to work. In that same case, if it was NumPy, it is supposed to be pip3 install NumPy. And that's simply because I think we covered this in class. The Mac operating system comes with Python already installed, but that one is Python 2. So we installed Python 3. So in order to use pip, you need to specify the kind of Python that you want to use. Okay, so I've already installed pandas. So I just have to come and import it over here. So I'm going to say import pandas as PD. So we spoke about this when we were dealing with NumPy. So doing import NumPy or import pandas is going to import it. But then when I say as PD, all I'm trying to give is this PD is an alias that I want to use. So instead of typing pandas all the time, I just want to be typing PD, just like a shorthand. So I say import pandas as PD, and in this cell, I'll do a shift enter. So when there is a star on that particular cell, then it is running. The moment you see a number show up, then that means that running of the cell is complete. So now we don't seem to have any problem over here. Now I just want to print the version of pandas that I have installed on my system. So over here, I'm saying print, then the PD dot underscore underscore version underscore underscore. So once I run this, do a shift enter, I get to see that this is a version of pandas that I am using on my system. Chances are, if you have to run this on your computer, you might have a different version because I installed or I had my pandas installation a very long time ago. So at least we've gone through the installation and importing. Now let's learn some terminologies around pandas that comes along a lot of time. So we need to understand what series and a data frame is. So the question is, what is a series? Now, a panda series is a 1D array. So last week, we spoke about arrays extensively when we were dealing with NumPy. Now, that concept is also here in a sense that when we talk about a series, it's a 1D array holding data of any data type. It is like a column in a table or a matrix. So this is just giving us a throwback to what we did last week. And then a data frame, as we see over here, when data set is multi-dimensional. So over here, we don't just have one column, we have multi-dimensional. So that means you have rows and columns. Then they are stored in a structure called data frames. So if a series is like a column, then the data frame is like the whole table. So over here, there's this image over here that probably will make things look a little bit simple for us. So we have 3 series over here. So the first series we have is like a series made up of mangoes. Okay. So, I mean, the idea or the thinking that I went through was, okay, maybe there's a farm. So maybe on a particular day, these are the mangoes that were harvested. Then on a particular farm, these are the apples that were harvested in terms of the values. Okay. Then on a particular farm, these were the bananas that were harvested. So with a single entries or columns individually, they are called series. Now, when we add them up, then we get not a series, but then there's like a data frame of fruits. Okay. So we have different series being joined together. And we are going to see examples of that. So now let's see how we can create a series from a pandas list, a series from a pandas list. Sorry, from a Python list. So we saw last week that, yes, of course, we can do this and pass in some data. Let's say 10, 20, 30, and then 40. So this is a list, and we've dealt with this over and over again. So I'll do a shift enter. It will run this cell. Now let me create a few more cells beneath this to actually do a preview of data. We clearly see that, okay, this is what we have stored inside of the variable data. If I'm to do a type data, we get a proper confirmation that this is indeed of a data type list. Okay. Now we want to create a series out of this, or a series which contains these values we have as the data. So now I can do PD. And when I do PD, or when I type in PD, I'm just calling the pandas. I've given it an alias over here. So when I do PD dots, once again, the dot operator, it's almost as if I want to go into it. So if I go into pandas, what do I get? I get something called the series. And this is basically telling pandas, or the kind of logic I'm trying to give is, okay, I want to create a series from pandas. So if I want to create a series, then a series cannot just be an empty series, even though we can have an empty series. But then what do you want to put in there? I want to put in data, which data is going to be from this list. So what I'm going to do is I'm going to save this in a variable called x. So this is what I've done. I'm saying that x is going to be equal to PD, which is pandas.series. Then I'm passing in this data from this list over here. So when I do a shift enter, everything runs perfectly. And now when I do X and do a shift enter to get a preview of this, I'm getting something interesting over here. Yes, the data is 10, 20, 30, 40. And that's exactly what I see over here, 10, 20, 30, 40. Remember, the series is just like a column. And that's what we specified over here. The series is a 1D holding data. So it's just one dimensional. We don't have rows and columns over here yet. So this is a series. Now you also see that we also have this 0, 1, 2, 3 just by this, okay? And this 1, 2, 3, who can just give a quick guess on what these 0, 1, 2, 3 might mean to this series? Who can guess? Yeah, an intelligent guess for that matter, what this 1, 2, 3 could mean.
All right, nobody wants to guess.
Okay, there's an answer in
Okay,
the
somebody, Mariama says index.
Okay, Apiaso is index. Okay, all right, that's good. So yes, that's true, because definitely we know that the with Python counting starts from 0. Okay, so we are going to see 0, 1, 2, 3 in that order. And currently we have 4 elements in here, and these are the indices, but then these are the original data. So having known that these are the indices, okay, this is the default thing Python gives us. So now over here, I'm saying that we can create a series with our own indices. So now this was the original series that we have created. We can, beyond 0, 1, 2, 3, 4, 5, whatever thing that Python gives us, we can explicitly tell Python that, no, this is how we want to structure our indices. Okay. So now this is what I'm going to do. I'm going to pass in extra parameters over here. So I'm going to say comma, and I'm going to specify an index. And this index should be a list. Okay. So in this index, I would want to say, let's say there's not just 0, 1, 2, 3, but then the first one I have over there was representing height in terms of the data. The second one was maybe weight. The third one was maybe age. And the fourth one was maybe, I don't know, something like distance. Okay, so when I do this, all I'm trying to tell Python is, okay, I don't want to have your 0, 1, 2, 3. I want to overwrite this with my own index, okay? And I'm happy you are the ones who brought that this could be the index. Indeed, this is the index. So now when I run this, do a shift enter, we don't seem to have any problem. But now when I do a preview of X, we get to see that, okay, things are beginning to shape up the way we want it, because we have now changed the default indices that Python gives us into ones that we have specified on our own. Okay, so this is what we have, and everything is looking good. So
Can pause 1 minute for me, please? If you have any comment or question, just raise your hand so that we can identify, and then I attend to you.
okay,
Go ahead.
all right, thank you, sir. So that covers we creating a Panda series with our own specified indices, okay? And later we are going to see how we do some manipulations with these indices. So now let's see an instance where we want to create a Panda series from a dictionary. Now this is an interesting one. So let's say I have a variable called new data. And new data is going to be a dictionary. So we know dictionaries are key value pairs of data. And in order to declare our own dictionary, we use the curly brackets this way. So let's say this one, the key is, let me say input 1. So input 1 is a key, and the value is 20. Then I'll do a comma, then I'll do input 2. So the key is input 2, and the value is, let's say, 100. Then I have another one, input 3. This is a key, and the value is 50. So this is my new data that I have over here. Now I want to create a Pandas series out of this. So once again, I'm just going to do PD, which is my Pandas, dots. Then I type in series. Then what do I want in terms of data? I want to pass in this new data over here. So let me save this in a variable called y. So I'm saying that y is equal to pandas.series. Then I'm passing in new data. So now when I run this, we don't seem to have any problem over here, but then something interesting is going to happen. If I'm to do a preview of y, I get, okay, my data shows up as the 20, 150. That's what we see over here. But right away, I get to see that the indices, okay, didn't go with the normal 0, 1. That's the default. It went with the keys that I provided for my dictionary. So over here, because Python is a key value pair, automatically, if I'm to do, or if I'm to create a data frame, a series out of a dictionary, then automatically the keys are going to be the indices, okay, for the values to be the actual values that I have over here. And this kind of makes sense intuitively and also just by way of grammar, okay? Grammar in the sense that, remember, when we're dealing with, for instance, let me just show you this. When we're dealing with dictionary, okay, this is still the dictionary. And we said that for Python dictionaries, they are ordered by their indices, okay? So over here, I can do something like new data. And if I'm to do the square brackets this way, okay, and I want to grab, let's say, what I have in 20, I just have to pass the how do you call it, the index, okay, the index, okay, so that when I run this, I get my 20 over here. Now, this is more or less a unique thing, and it is reflecting in the index I have over here. So that's what, like I said, makes sense over here. In that same way, we know that this is our y, okay? Our y is showing up this way. If I want to grab just 20 out of y, if I'm to do this, and for instance, pass in input underscore 1, now something interesting is going to happen. I get back my 20. So even though this one originally is a dictionary, new data, and we can grab specific entries of our whatever, okay, of our data based on the index or the index, this y is a series, a Pandas series, and we can also, based on that logic, grab specific entries based on the index, and that's what we see over here. Now we are going to delve deeper into this later on, so don't worry. Okay, so now we've gone through the series and we can do quite a number of things over here. Now let me show you one other thing. So we can do this way, and then we can look at this. I can use y.lock. There's a lock method over here, and this lock method will give me the opportunity to grab things also by the row. So if I'm to pass in the input underscore 1, I believe, if I run this, I'm still getting the 20 over here. So it is kind of behaving the same, okay? It is kind of behaving the same, except that this lock gives us some level of flexibility, okay? Some level of flexibility in the sense that I can do input 1, comma, then another, let's say input, let's say 2. So basically, I'm trying to say that, okay, I want to grab the data from input 1 and also the data from input 2. And that's what I have over here. So when I run this, we are getting an issue over here. Let me see. It says there are too many indexes. Okay, don't worry, we are going to have our way around this later on, but just keep in mind we can do something like this. Okay, so now let's go back to the data frame. So clearly the series was just covering single columns, okay, and we can see what we saw over there. Now let's look at the data frame. Then the data frame is going to be something that we can have rows and columns. So let's get a data frame from a list. So once again, I'm going to have data, and this is going to be a list. So let me use the data I used before, 10, 20, 30, and then 40. So in order to create a data frame, all that I need to do is I need to do pandas or PD dot then data frame spelled this way. So remember the case sensitivity of Python. If you spell it any other way than this, it's not going to work. So the D is capital and also the F is capital. This is almost like a camel case notation that we see over here. So I'm going to pass in data over here, and I'm going to save this in a variable called Z. So Z is going to be equal to pd.dataFrame, and I pass in the data that I want to create some kind of tables, rows, and columns out of. So when I do this, everything works perfectly for me. And then if I'm to do a preview of Z, now something interesting happens. Now, the interesting thing happening over here is like that, unlike when I was creating, let me also create a series out of this so that you see exactly what is happening. So X is going to be equal to PD dot the capital series as I have it this way. And I'll pass in data. And now let me do a printing of X. Okay, so this is what we have when we create a data frame out of the same value data, okay? And this is what we have when we create a series. Now, clearly, just by looking at it, you can see that this one has some level of structure, okay? In the sense that, yes, we get the indices showing up over here. Over here too, we get the indices. But then over here, you see that we're also getting some columns showing up over here. So it is even starting to count the columns that we have. Okay, so we have column 0 showing up over here. Over here, we don't seem to have anything with regards to columns. It's just a single column data structure. So that's one clear distinction that we see over here. But we can expand this, okay? We can expand this in a sense that, okay, so we know that we can change the indices that we already covered. So for instance, if I come in here and do an index and pass in, let's say, this is going to be, and let me just do this Monday, something like Tuesday, something like Wednesday, and then Thursday. So when I do this for the index and run this, now clearly the index has changed. I can also change the column. The default is 0, 1, 2, 3 if I have multiple columns. So I can come in here and also do a comma and now change the columns. So I'll do a columns and then I can pass in, let's say, the heights, okay? So when I do this, I don't seem to have any problem. I've run that cell. Now, when I run this, clearly you can see that the column has also changed to height. So probably this was some data I collected from some random people. So on Monday, collected data from 10 people. On Tuesday, probably 20 on Wednesday. And we can go on and on with this. All right. So this is the beauty about data frames and series. Now, the key thing is you are probably not going to have a data frame with just one column. Then you could have just used a series to accomplish that task, okay? So we want to have multiple columns over here. And in order to get this going, let me just do this. So let me, first of all, get rid of this temporarily. I'll come back to this. But then this is my list, okay? I can have a list of lists. So I'm going to encapsulate this list inside of a bigger list, okay? Then I can proceed to have other data. So let's say I have 100, 200, 300, and then 400, okay? Then let's say I have another one, which is going to be, let's say, 1,000. I'm using different variations of data so that at least it is very conspicuous for us to see the differences in there. So let me do 3,000 and then 4,000. So that's the data, the original data that we have. And then this time around, we are creating a data frame based on this data, and we are just changing the indexes over here. Okay. So now when I run this, we have an issue. Let me just get rid of this index over here. So everything is looking good. We'll come back to the index. So now we have this showing up over here. Now, clearly, you could see that this one will go into the first row. That's what we see over here. The second one will go into the second row, and then the third one will go into the third row. So it goes on and on like that, okay? Clearly, if there's some kind of a mismatch, then we are going to see that this one is none. And later on, we are going to see how we deal with none, okay? So none means there's nothing over there, but based on the structure, no, under normal circumstance, something was supposed to be there, okay? If in the first one, okay, we run this, you see that there is none over here in the first one. It doesn't really matter where you deleted the data from, but then based on the structure, it is only going to assume it was the last one. Okay, so we see a number of nones over here, and we are going to work with nones. But then let's make it something that will not give us any none. So we have everything sorted out perfectly. So we have this for our data frame. So rightly so, we can change the columns and the indices if we want to. So now let me do the index, and for this index, I'm going to specify, okay, so it's going to be the rows, okay? The index are going to be the rows. So I just want to have, let's say, something for, like I did Monday, then Tuesday, and then Wednesday. Then for the columns, I'll come outside of this and I'll type in columns. And please, this columns is with an S, okay? Like columns, plural. So for the columns, let's say I want something for height, and the second column was for weight, and the third column was for age. So I'll do this, and then once I run this, this is exactly the data frame that I was looking for. All right. So this is just by way of doing it. Now, in order to get this example working, okay, let me just get rid of this index, okay, so that we can just have this, okay. So we are still going back to the index 0, 1, 2, 3, the default one. Now we can pass data using the lock method, even so that we looked at in the case of the series. So all that I mean is, okay, I can do Z, which is the data frame itself. Okay, when I do a dot lock, and then I pass in an index of 3. Currently, Z is not having an index of 3. So definitely when I do this, it's going to tell me that, well, there's a problem. It says the problem is, it says there's a key error, okay? And it's showing that a 3 is a key error. But then when I do an index of 2, it tells me that, okay, for 2, we have for height, I have 1,000 over here. That's what we see over here. For weight, I have a 2,000, and then for age, I have a 3,000 over here. Okay, but then I can do an index of 3 and say it's equal to, and I'll pass in some data over there. So I can say, let's say 1.1, 2.2, and then 3.3, just for us to have that kind of entry. So I'm now passing the data in there. When I run this, everything is looking good. Now, when I do a Z, a preview of Z, now I have a new row showing up with the data that I pass in there. So clearly we are using the lock method to grab things by the row. And over here, we specify that we want row 3. And for row 3, this is the data that we are passing in there. For some reason, if clearly it was expecting 3, we pass 2, then we are going to have a problem over here. Okay, so it could not broadcast the input array of shape 2 into 3. So whenever we see this, we should know that, okay, the lock is a little bit strict over here. So we need to make sure that things are perfect in terms of how it is supposed to look. So everything is looking good. Now, okay, so we've seen an instance where we can create a pandas data frame from a list. That's what you saw me do over here. Now let's look at using the lock attribute to return one or more specified rows. And that's what you saw me do earlier on. So let's say I have the Z, okay? Z is what I see over here. And I want to grab more rows, not just one row, but then more rows. So for instance, if I do z.lock and I pass in 2 over here, or yeah, if I do 2 over here, then clearly I'm just getting one row, okay? But then let's say I want to grab row 2 and then row 3. This, okay? Yes, I can do a comma 3 over here. And when I do it this way, we are going to have an error. And that's what we saw earlier on, okay? But then I think the issue has to do with we making sure that we wrap things up in another square bracket. So this is more or less like the data we are passing in there. And this is the original bracket that should have been there. So now when I run it this way, we don't seem to have any problem. And we get exactly what we specified for. So we have the index of, the data from the row 2, and then the data from the index 3 or the row 3. It could have been, let's say, 1 and 3. When I do 1 and 3 and run it, it is exactly showing me the data I have in 1, which is the data in the hundreds, and then the data I have in 3, which is what I see over here. Okay. So earlier on, Dr. Mills spoke about we learning some of the sources of the data sets that we'll be using. And it is very important because as much as we may be generating our own data, chances are if a data already exists, there's no need reinventing the wheel, okay? At least maybe for some proper analysis of your work, if there's a need for you to generate data, you can generate your data and then compare it with the data that already exists, and maybe do a proper analysis, build a model for the one that's already exists, and also build a model for your synthetically generated data and do that comparison. So you have a benchmark, and that would be a very good work to look at. So there are some few examples of places that we can find data. So the first one we see over here is Kaggle. We are going to go there and we are going to see some data sets. And then we have the UCI machine learning repository. This is the University of California in Irvine. They have a data set repository that we can get data from. And of course, we can get data from experimental trials. So maybe you go to the lab, you conduct some experiments, you get some data. You can, based on that data, and for instance, maybe you have about 1,000 data sets, okay, instances of data. And you just want to make a prediction, but then you are not getting so much of value. You can just create a model to learn from that data set you got from the lab and to create your predictions. So one of the data sets that we are going to look at is for us to learn.
Ken, let me add on that also for biomedical engineering students, we have MIT. They also have a data set,
Okay.
Which has a lot of medical related information.
Sure.
So we have used that also for some projects as well.
Okay. All right. So the list is exhaustive. Okay. You can, so let's go to Kaggle and see. And now Kaggle is Google's own how do you call it? One of the subsidiaries of Google. Okay. So you can get a number of things over here. Okay, no problem. So normally you'll be asked to sign up and stuff like that. But then even without signing up, you can look at things. And from time to time, they organize competitions which you can join. You can win some money. But then even if you don't win the money, at least you learn a thing or two. Okay. So almost every now and then there's some data. So there are some popular ones like the Titanic data sets. where I think with this particular data set, they looked at the chances of survival based on some classifications that were done. So it turned out that in the Titanic, and I think those of you who have watched the movie, there was some elements of that was shown in the movie. If you are from, I think they started saving when the lifeboats were being dispatched. They first looked at children and women, and then later they went to the rich people. So the poor people were locked somewhere. So this is a data set that looks like your chances of surviving, given some attributes that you have, the tickets that you paid, your gender and other things, your age and so many things. So this is something we can, look at if we have time. But then, so this is the data. Let's go to the data. So with this particular one, it has already been split into two. So there's a training data set and there's a testing data set. And then the variables over here is the survivor. Okay, so this one is purposely for classification. So if it is 0, then that means your survival is no. If it is 1, then your survival is yes. And you can see that the variable, one of the variables we have over here is the class, okay, or your tickets class. That's your tickets class. So they had first class, second class, third class, and in the video, somebody even didn't have a ticket, but then managed to find his way there. Then we have one for sex. Then we also have one for age, and then some things over here. This one is of siblings, the spouse board, aboard the tickets, then of parents, then the ticket number, the passenger fare, the cabin number, and the port of embarkation and stuff like that. So it contains a lot, and these are some descriptions that have been given. So for instance, when it comes to the class, you see that the first class are those in the the rich people, there's the middle class, and the very poor people are what you see over here. So we can go on and on and on with this. But then if, let's say you come here and you just want to have, let's say, think about some data, maybe you are thinking about some cancer data set. So I can come in here and type in cancer, press enter. And then there are a lot of data sets that a lot of people probably put up, some of which may not be medically verified and stuff like that, okay? So you might want to do a filtering over here to look at, for instance, you see that we have some from MIT. So when you look through this, you can actually do the filtering yourself, okay? So over here, you can see that, okay, we have some data sets over here. So this one is breast cancer. We have skin cancer. We have cancer malignant or benign tumor. And we have quite a number of them, okay? So depending on what you want to do. So for instance, if I come to the skin cancer, or the breast cancer, I come in over here. This one has no description. So I don't even trust the data set yet. But then this MIT you see over here is another MIT license, which means it is open source. Anybody can use it for educational purposes and stuff like that. So we get some things over here, but then maybe there's not something I might want to go in for. So you can just do this exploration yourself to actually get good data. Now, the one that we are going to look at is what we have here as the IRIS data sets. So with this IRIS data sets, what is happening? Okay, people also have their own modifications of that data set. Don't worry. So we can look through and get the proper one. We can look through and get the proper one. That's from Kaggle. But clearly you can see that there's a lot of data set repository and there's a lot of things that we can use over here. Now, if I'm to go back to what we're dealing with, so now I have this, how do you call it, the original data set over here. So when I click on this, it takes me to the IRIS data set. So this is the original one, and this one is from the UCI machine learning dataset repository. This was published about 8 years ago. So this like the proper one, okay? So we come in here and it says this about the data set. So the IRIS data set was used in RA Fisher's classification 1936 paper. Okay, the use of multiple measurement in taxonomy problems and can be found on the UCI machine learning repository. So it includes 3 IRIS species with 50 samples each, as well as some properties about each flower. So it gives you the columns, okay, the various features. So there's an ID, there's a sepal length cm, there's a sepal width cm, there's a petal length cm, and finally you see the classification. Okay, there are 3 different types, and it gives you some kind of information as we have it over here. Now I can simply do a Google search of UCI machine learning repository. Okay, so when I come in here, over here too, I can click on data sets and I can search. So in here, I have one on IRIS, the popular IRIS data sets. And then this one is on dry beans. So for those of you in food science or food process engineering, you can look at these data sets and how you can get some insight out of it. You can also look at the heart disease. So on your own, you can, I expect you to probably download one of these data sets based on the things that we'll be learning today. You can try your hands on some of the things that we do. And these are some, this one is the breast cancer Wisconsin diagnostic data set. This is the quality of wine data set, the bank marketing. So there are lots of different use cases and different data set that we can look at, okay? So let's look at the dry beans. And it says the subject area is mainly in biology, okay? It is multivariant. It has almost 13,000 or over 13,000 instances, and these are the features. And it was donated. So at least this one looks good. And these are the number of people who have looked at it and stuff like that. We can also look at the heart disease. And so now let's look at the heart disease, at least for the biomed students. This is something that you might be interested in. So it says the data set contains 76 attributes, but all published experiments refer to using a subset of 14 of them. In particular, the Cleveland database is the only one that has been used by machine learning researchers to date. So so you can take a critical look at this and it looks good. So these are some of the features. So the variable name, yeah. And like Dr. Mill said, some of the features you see over here are very technical. So you definitely need the experts to help you understand, for instance, the serum cholesterol. I have no idea what this is. The resting blood pressure. You may know blood pressure, but then the question is resting blood pressure. So these are things you may not have all the knowledge, but once you get a subject matter expert to explain to you exactly what these are and what they are used for, you can get a very good understanding of how to work with this. Okay.
Sorry, is any biomedical student on the platform? Anybody from biomedical? Is Fifi on the platform? Is Akofa on the platform? Any biomedical person? So we don't have any biomedical. Okay. Please move on.
Okay, sir. So we can go on and on and on with this, but then let's stick to the plan that we have over here. So yes, these are images I found specifically on the IRIS data set. So for the IRIS setosa, they are all flowers, okay, the IRIS flower. But then it turns out that based on the research that Fisher did so many years ago, he was able to identify that, even though they are all IRIS data set, but then based on the length of the sepal and the length of the petals, we can have different classifications of it. So clearly, when we look at the IRIS setosa, there's one class or there's one category they refer to as the setosa. So normally, these are like the width of the petals and also the length of the petal and stuff like that. And then there's another one called vesicular, okay? So this is how it looks. Clearly, you can see that there are differences over here, but then they are of the same species. And then there's Virginica that also has different width and length of the petals and the sepals. So over here to, at least based on the imports or the downloading that we did, I actually included the IRIS data sets in here. So I've included the IRIS data set in here. Now I have two of them. I have the IRIS data set and I have one that I call the IRIS_modified data set. So I've done some modification on the original one over here. And the modification is like that, okay, the IRIS data set is, nearly perfect. So we want to put ourselves in a typical situation where there are some missing rows, missing columns. How do we deal with duplicates? How do we handle the outliers and all those things? So those modifications have been done to this one. It's the same data set. So now let's see how we get the data set proper. Now, once again, let me come back to this. Now, this data set, let me zoom in. This data set is also, when I do a right clicking of this to check the properties, you are going to see that the file format, okay, is .csv. CSV stands for comma separated values, okay? Comma separated values. Now, if I open it up right away, by default, it is going to open up in Excel. And it might look like it is actually an Excel kind of structure. But then the point is, if I am to do a right clicking of this and to open this up, for instance, in Notebook, this is where we actually get to see where the name is coming from. So it says comma separated. So you can see that, yes, we have the values. And let me open it up in, how do you call it? In Excel, or sorry, in this one once again. So yes, the data is what we see over here. Let me just put this side by side. So the data is what we see over here, but opening it up in, how do you call it, in Notepad is giving us some kind of a true sense of why it is called comma separated. So over here, you can see that all the values are separated by commas, okay? All the values are separated by commas, but then when you open it up, by default, it opens up in Excel and you don't see the commas over here. So these are comma separated values kind of a data. So clearly, you can see that we have the ID. These are the columns, okay? So we have the ID, we have the sepal length, we have the sepal width, we have the petal length and the petal width. And then based on these values that we see over here, it is going to be classified or categorized as within the species of either Iris setosa, and then we have Iris versicolor, and then finally we have Iris virginica. So there are different things that we are going to see. All right. So now let's see how.
Ken, can you pause for me? So remember, if you look at the data that we have seen now, which type of learning do you think we can use this data for? Is it supervised or unsupervised? Anybody?
Okay.
Abba Sally says supervised.
Okay.
Can you explain why you say it's supervised? Or does anybody agree with her? If you don't agree with her, you can also share your thoughts. But Abba, can you explain why you think it's supervised? Or you just guessed?
Please, I know, but then I don't really understand why it's supervised.
Okay. So can somebody who knows explain to us why it is supervised? Who would like to explain? Yes, okay. So Ikechukwu, you said because the target variables have been what? I can't see the message again. He said because the target variables have been assigned. Very good. So anytime you have a data set and you take the number of samples, see that the last column says species. So the species is the target. So for each of the sample information, they will tell you that, okay, for this particular information we are giving to you, or this flower we are giving to you, it belongs to this particular group. So the target is this. And this is why when we started the beginning of the discussion, showing you how to do how the learning is done, we see that we said if you put this input, the input are sepal length, sepal width, petal length, petal width. These are your variables. If you apply this input to your model, it will predict a particular class for you that this should belong to. So you are telling it that this is what it should look out for. If it gives you something different from this, it will see it as an error. So that error will now be, the system will go back again and then do optimization to minimize the error. So this is what we started from the beginning of the discussion. When we started with them, I think we were using some calculations. We gave you some small calculations to do things like that. So when we have information and they provide some target for us or expected output for us, then we will call this a supervised form of learning that we are going to do. If we don't have any species there, then the system has to sort itself out to identify which will be what. And that is where we call it unsupervised. In that case, there's no target guiding us in the learning process. Please, I hope we are okay on that. So, Ken, you can please proceed.
Okay, so let's make progress. So now we want to import that data, okay? And remember, it is in the folder that we are working in. So it is in this folder. We have this data, iris data set over here. So I'll come in here and now once again do PD, which is pandas dot. I want to go into PD and then I want to use a method called read underscore CSV. I'm saying read underscore CSV because this is a CSV file, okay? But the read is not only CSV that we can read. When I do read, clearly you can see that we can read clipboard, we can read CSV, we can read from Excel, we can read from a lot of other different file formats, okay? But then chances are most likely you're either going to read from Excel or from CSV if you don't want to have a lot of issues with your data set. So we are going to read from CSV and then we have to pass in a string. Now this string is going to be the name of the data set. So I'm going to do iris.csv. So iris.csv, and I'm going to save this in a variable called data. So this is what I have over here. So now let me just show you. This is the data set, okay? When I do, once again, check out the properties, you see that this is the name iris, okay? And the extension is what I see over here, .csv. Okay, so now I'll do this and run this. I don't seem to have any problem over here. Now, there are some, potential issues that you may run into. And the problem is a lot of the time, you get so overwhelmed, you forget about the extension. Of course, when you forget about the extension, you are going to catch this error. And let's see what the error says. It says that there's no such file or directory as what you have specified, iris. So it was looking through your directory, it didn't see iris. The actual thing to do is to also include the .csv file format. So now when I do this, everything is looking good. Now, when I do a preview of this data, I get to see exactly what I would have seen if I'd open it up in Excel, okay? Except that this has the structure of a data frame, okay? So once again, I can check the data type over here. If I'm to do a type of data, you get to see that this is a pandas.core.frame.data frame. It is telling me that this is a data frame. So once again, the things that we're doing, using the lock or doing some other things, we can do the same things over here and we can get exactly what we want. But beyond the lock and other things, there are some few things that we want to concentrate on, okay? And the first one that we want to see is using the head method. So there are lots of methods that we can use, and we can apply them on the data sets or the objects that we have created out of this PD or pandas. Remember, this is all object oriented, okay? So now when I come in here, and if I want to just see the first 5 rows of the data frame, I can use a head method. So now I can do data, which is the object dot head this way. And now call this. And now when I run this, I have exactly the first 5 rows. So now the index starts counting from 0 up to 4. So clearly we know that these are 5. And then the ID is actually in the data set itself, okay? So I have this ID. And then we have this attributes or columns. So we have the sepal length CM, the sepal width CM, the petal length CM, and the petal width CM. And the species are the categorizations that we have. So that's just with the head. Now, if I pass in, let's say, a 10 over here, then clearly, by default, when I just do data or the object.head, use the head method, it's just going to return the first 5 rows. But then when I pass in 10 over here, what I'm trying to say is return the first 10 rows. And that's exactly what we see over here. So it starts from 0 based on the index and ends with 9. It returns the first 10 rows. And then when I do 20 over here, of course, it will return the first 20 rows. So that's looking good. Now, we can also use the tail method. So once again, I'll do data.tail. When I leave it blank like this, if the head was returning the first, then the tail is definitely going to return the last. This one, just by our own intuition. So now when I do this, clearly we see that, and let's just check by the indices over here, okay? So we have 145, 146, 147. That's the last. And then if I pass in 10 over here, it is definitely going to return the last 10 rows for me to see. Now, if I do data.shape, remember we spoke about, a little bit about shape when we're dealing with NumPy, okay? So this one, so this one, tuple object is not callable. So this one is an attribute. So we just have to do data.shape and it's going to return the shape. Now remember the first one, it is RC, okay? So the row by the column. So it is telling us that we have 150 rows by 6 columns. So that's what I said. If the Electoral Commission or the NHIE, okay, the NIA, okay, the National Identification Authority, has over millions of people in their records. If you are given that data set, you don't have to be going through one by one. You can just do this and know that, okay, I have 150 instances or 1 million instances of data sets. All right. And the columns are definitely going to be the vertical cross section. So over here, this is the first column, which is the ID. This is the second column, the third column, the fourth column, the fifth column, and this is the sixth column. Okay, now we can also use the info method, and this one is going to return some information about our data set. And this is actually a good thing. So now when I do data.info and run it this way, call this method and run this, this may look little, but then trust me, it is a lot, okay? It is giving us a lot of information that is going to help us. So the info, like I said, gives us some information about the data set. It is kind of giving us a high level overview, like a plan, like a bird's eye view of our data sets. And we can quickly see some problems with our data set just by using the info method. So now let's see exactly what this one gives us. Now, the first thing we see over here is that it is giving us the index range. So the index is what it is counting based on its 0 index and starting from 0. And it is telling us that it has 150 entries. And the indexing starts from 0 and ends at 149. This one makes sense based on our understanding of NumPy and Pandas and how Python counts starting from 0 and all that. Now it says that the data columns, it has a total of 6 columns. So this one too makes sense. We can simply count it over here. Imagine there were about thousands of columns. Counting it one by one was going to be a complete waste of our time. Just by doing this, we have a sense of the data sets. Now let's go in depth into the individual columns. So it tells us that, okay, for the ID column, or for the column, we have one with the name ID, we have another one with the name sepal length CM, we have another with the name sepal width CM, we have another with the name petal width CM, sorry, petal length CM, and then petal width CM, and then finally we have species over here. Great. Now, there's this side that gives us a lot of information. Now, it is telling us that for the ID, we have 150 non-null. Non-null basically means not now. Remember earlier on when we were dealing with, and we are going to come back to this because in the modified data set of this same Iris data set, I have some, I've deliberately expunged some entries over there. So we are going to see some now in there. But then we dealt with an instance, that one should be here. Okay, I think I cleaned it up. But then you remember there was an instance where I didn't bring some entries over here. So we saw capital N-A-N, okay? So those were showing up. Very good. So those were showing us as now, okay? And over here, when we use the info, it is telling us that there are no, there are 150 not now. So that means there's something in there, okay? So we can actually look at this. The index range is telling us that there are 150 entries. And it is telling us that there are 150 not now. So that means there are 150 entries over here. So it corresponds to this. So clearly we can see that for all our entries, there are no now entries over there. Everything is filled up. Everything is filled up. So this one is basically giving us some idea that, okay, we don't have any problem with our data set. Everything is filled up. But clearly we can also not conclude on this because what if there are some outliers? Okay. For instance, we could see that our data is having, let's say this one, 2.4, 2. Then all of a sudden we have 20,000 maybe showing up over here. That's definitely going to be an outlier. We are going to see how we can identify those outliers because we cannot look through it one by one. If there are about 1 million instances of our data set, we cannot go through one by one. And if there's some 1 million hidden somewhere or some 100,000 hidden somewhere, which is an outlier, it is going to show up as something which is filled. So the not now is not going to expose it. All right. Now, the last point or the last section we have over here is the D type, which is also showing us the data type. So clearly for the ID column, the data type is an integer. And then for the other ones, clearly you see that this is a float. So the float, the float is obviously going to be the, I'm trying to mute some people. Okay, so the float is definitely going to be the decimal point values as we clearly see over here. And the species, we see the species as objects, okay? So let me just show you. The species, we see them as objects over here. That's another way of telling us that it is a string one way or the other. And we are going to see how we can modify certain things to be in a certain way, okay? Which we are going to come back later to. So there's this. Now let's come to an instance where we want to do proper pre-processing and cleaning of our data, okay? So now, data cleaning means fixing errors or bad data in your data sets. Now, this is a pre-processing activity that needs to be carried before using the data sets. So now, bad data could be a combination of the following. So we can have empty cells or null values. We can also have data in their wrong formats. We can also have, completely wrong data. And then we can have duplicates, which may not be a good thing to do or to have. So now let me just create some data over here. And once again, I'm going to use Panda. So I'm going to say pd.read_CSV. And now what do I want to grab over here? I want to grab the iris_modified data set. Okay, like I said, this one has some null values, it has some duplicate and stuff like that that we can look at. So I'm going to say I want to grab iris_modified.csv. So when I run this, I don't have any problem over here. So now when I do a preview of data, I get some interesting things over here. Now, purposely, I made this in a way that is going to be very obvious, because over here, we are going to see, oh, the first row, we are seeing some NaN over here, which are some empty values, okay? If I'm to properly open this data up, we are definitely going to see that for the first row, okay, that's clearly what we see over here. So this is the first row. We see that this one is empty. The second one is empty. The third one is empty. And even on the fifth, for the petal length, this one too is empty. And that's exactly what we see over here. The first one is empty. The second one is empty. This one is empty. And this one is empty. Now, I decided to put it at least at the top, so that even without, because imagine if this was somewhere 73, okay, maybe on the 73rd row, then clearly these ones were going to be filled up. So we are definitely not going to see it properly. But then I just want to show you at least at the top over here. Now, over here, we get to see that, well, the number of columns hasn't changed, but then the number of rows, we see that we have 154. The original data set, which is what we see over here, okay, yes, this data, okay, we see that we have 150 rows by 6 columns. So by having 154, chances are there are some duplicates in there. So I brought all those things up just to make sure that we have a sense of how we can correct things up over here. So everything is looking good. Now we have this. Now let's look at data.info. Remember, we use data.info to get some brief overview analysis of our data sets. So now when I do this, now it is getting very interesting over here. So now see, I have the index range, which shows us that, okay, I have 154 entries. And for these 154 entries, it is starting from 0 and ending at 153. So this one, it is uncontested. We don't have any problem with that. Now for the data columns, we have a total of 6 columns. This one too is uncontested. But then the problem we have is, okay, for the ID, we have 154 IDs, not now or not now. And the number of entries we have is 154. So this one, we don't seem to have any problem. But look at this. For the sepal length, we have 153 not now. But then the actual entries we have over there is 154. So actually what it means is, at least we have a 1 now entry in there. But the question is, where exactly is this 1 now? We cannot go through it if there's only just 150 instances. So maybe you can spend some time, maybe in less than 10 minutes or maybe 20 minutes. You can go through this and get to see this. But look at the bigger picture. Hundreds of thousands of instances, 1 million of instances. You cannot definitely go through. We are going to see some quick ways that we can do that manipulation. In the second case, as we have over here with the sepal with CM, we can see that we also have 150 not now. So things are in there in those particular spaces. So if you have to do the math, then definitely we have 4 nows over here. And this one too, clearly you could see that we have 2 nows, and it goes on and on and on. So clearly we get a sense of how the info method, just by looking through this data as we have over here, or this analysis as we have over here, we can quickly see that no. So now the general rule of thumb is, if the number of non-nulls does not correspond to the number of entries, then there's a null entry over there. And the simple thing for you to do is just to do the math. Okay, this one I have 1 over here, which is actually empty. Here I have about 4. Here I have 2. Here I have about 7. And it goes on and on. Okay, so now let's see how we can remove the null values. So once again, let's get a preview of our data, and I'm going to show you something interesting over here. So just looking at the data sets, at least with this one, we can see that the first row, there's a null value over here. The second row, there's a null value. The third row, there's a null value. And of course, this one too, there's a null value. So if I just want to drop the null values, it is going to drop everything that has null in there. Now, the question is, do we actually want to drop the null values, or we want to do something, maybe a modification, trying to find something to replace it and stuff like that? That one would depend on the kind of problem you are solving. So for instance, a typical example, let's say you have about 1 million instances of data, and then there are about 1, 2 null values in there. Trust me, dropping those 2 null values, or dropping just 1 null out of out of a million instances, is definitely not going to skew your work, or it's not going to make your data so much of a bad data set. Okay, because of course, there are some statistical inferences in that data that will not change if you just take 1 out of 100 or maybe a million instances. But then if, let's say, you have 150, like we have over here, and you have about 50, that's like 1/3 of your data set. So you cannot just drop them and think your data is going to remain the same. No. Okay. Even if you have 150, and let's say they're about 10, 15, okay, it's quite significant. So there are ways that we go about this, depending on the use case or the problem that you are faced with. If you have 1 million instances and there's just 1 null value, you can just drop that row and we are good to go. So now let's see how we can drop this. So now, if I do data, which is the original data set dot drop any, there's a method, and call this method over here. This is going to drop all the null values. So now look at this. Currently, you can see that on the first row, we have a null value over here. So definitely this is going to be dropped. On the second row, we have a null value over here. This is going to be dropped. On the third row, we have a null value over here. It's going to be dropped. On the fourth row, we have it doesn't really matter the particular column where the null value is. Once there's a null value in that particular row, then it is going to be dropped. So when I say drop any and run it this way, I mean, it works like magic. So now clearly you can see that the index or the indices we have over here definitely is now starting from 4. And that's simply because from index 0, it found out that, well, there's 1 over here that we need to drop. Index 2, there was another one here that we needed to drop. 3, there was another one here. There was 1 here. So it is starting from 4, where there was no null. So it didn't drop anyone over here, or it didn't drop the entire row. So that's what we see over here. Now, the problem is if I do data.drop any and run it this way, yes, it had dropped the null values. But then when I come back and do data, I am getting back the original ones with the null values over here. So basically what this is happening is, okay, in order to be proper in terms of our approach, we can do 2 things over here, okay? And I'm going to show you. The first one is to, let's say, have a new variable. So I'm going to say clean data is going to be equal to the original data dot drop any. So now when I run this, everything is looking good. Now when I do a preview of my clean data, now I still have the data that the null values are dropped, okay? Now, once again, if I come back and preview the original data, I still have my null values in there. Now, I can still do data dot drop any this way. And this is going to be dropped. But then when I come back and do data, I'm still going to have this problem. Okay, not really a problem, but then this is how it's supposed to be behave. So now I can say, I can pass in an attribute over here, which is in place. Now, when I say in place is true, then this one is going to make sure that, well, I'm dropping the NA or the null values, and I'm going to replace that with the original data set that I have. So now when I run this, yes, this one works. And if I run data again, it is going to make sure that everything is dropped henceforth. So now I run data again, and now all my null values are dropped. So it's pretty much, depends on whatever thing you want to do. But now look at this. After dropping my null values, okay, currently you see that we have 140 rows by 6 columns. So now when I do data.info this way, I now see that, okay, I have 140 rows starting from 4 in terms of the indices, okay, and ending at 152. And clearly, I can see that there's a match over here with each column. But then I was at 150, I've dropped 10. To me, that can be significant because, first of all, our data set is even small. Okay, if you are working with data and you have 150 and you are dropping 10, then it doesn't look good, okay? So we can actually look at things in a different way. So we can actually fill this with some values. And with these values, we can use, for instance, maybe some arbitrary values that we may decide on, okay? Or we can decide to probably fill it with a mean, or the median, or the mode, or any other statistical inference that we may come up with, okay? So of course, when we fill it with a mean, basically we are filling it with the average. And it kind of makes sense if, let's say, you have, with this particular one, okay? Because the mean is the middle ground, okay? The middle point in terms of your data set. So, and we are going to see a lot of means and some of these things as we move along, okay? Because even with some predictions, we are going to use, or we are going to rely on the means to do those predictions. At least not not straightforward, but then it's going to be part of the computations that we are going to do. And the simple example I use is, okay, so if I walk into, for instance, a typical level 100 class, okay, let's assume they are all regular students. There are no mature students in the class and stuff like that. And let's assume, and of course, I'm assuming a lot because nowadays you can have a 50-year-old even in primary school, so let alone university. So let's assume all things being equal, the person went to a regular school, they didn't have any breaks in their life in terms of education, went through the regular thing. Chances are, most level 100, the age group is probably going to be around, and nowadays we have a lot of people going to school very early. So let's say around 17 to let's say 20 for level 100. A lot of them will be within that age bracket, 17 to 20. So now if I walk into a class at JQB, there are about thousands of students over there. And I'm told, oh, sir, one of our mates just went out. And maybe I'm picking some data that needs to be processed, maybe to pay students some money or something. And I'm to fill the forms. Well, the question is, do I wait for the student who is probably going to spend all day somewhere, or maybe just drop the, if I drop the NA, that means that student is not going to get the money. Okay, maybe, you never know. You may never know. So maybe I can fill that particular entry with the average of the class. Okay, and in that average of the class, if I'm actually reporting my findings to the VC or the dean or any other person who sent me, I'll say that, oh, when I went there, one person was missing. I didn't get the age. However, I couldn't also wait for that person because we needed to send this to the education ministry or whatever. So the VC or the dean or whoever sent me, the HOD asked me, so what did you do? I cannot say that, oh, well, I can say that, well, okay, looking at the class, I think their average age will be around 18. So I put 18 over there. Then maybe the VC looks at the data, said, okay, for all level 100 students that we, for instance, admitted, we have the range from 17 to 20. So if you use 18, even if you are not wrong, or sorry, even if you are not right, you cannot be too far off. It is either +1 or -1 that you probably miss out. Those ones are permissible, but not when the VC or the dean asks me, so what did you do? Oh, okay, so I just picked the number. So which number did you pick? What informed your decision? I just picked 10. And the question is, 10. Is the person in class 1 or day nursery or whatever? So we need to be guided about certain things. And a mean can actually represent something for us. Okay. So having said this, we want to fill the null values. Okay. So in order to do this, let me just do the data set again. So because now if I do data, everything has been, all the duplicates have been removed. Okay. And I don't have the benefit of doing the replacement now. So now let me just do data is equal to pd.read_CSV. And then what do I want to get? I want to get the iris_modify.csv. That's the data set that you have been working with. So now when I do data, clearly I have the null values showing up over here. So now I want to do a replacement, or I want to use the fill any method. So now when I do data.fill any this way, obviously, and this is why some of the things we learned earlier on is beginning to make sense. Picking names that are descriptive. So for instance, you saw drop any. You are dropping all the null values. You are filling any. You are filling. Now the question is, what do you want to fill with? Okay, I want to fill with 100. Okay, this is what I was thinking. So I want to fill with 100. The moment I do this, once again, clearly you can see that now the initial NAs have now all been filled with 100. The initial NAs have all been filled with 100. And now, once again, if I do data, I still have my NA over here. So clearly, if I want to make sure that this, I have to do a replace, in place is equal to true. But then I don't want to do that because that's also going to change the data, okay? So let's say I'm going to have, once again, something like, I can still use the same variable and say data is equal to this, but then I don't want to have that. So let's say I can say clean data is going to be equal to this. So I filled NA with this. So let me do a Control-C and a Control-V to have a preview of this. So I filled all the null values over here with 100. But like I did indicate, using the the classical example of the student and other things, this is just an arbitrary value that does not make any statistical sense, because then clearly these hundreds are going to be straight away outliers. These hundreds are going to be straight away outliers because the values are not even conforming to anything over here. And that's why I said we can be very specific over here. So over here, yes, maybe I want to fill all the NAs associated with petal width with 100, but then all the NAs associated with, for instance, petal length with 50. Because I'm using just fill NA, it is filling all the NAs. It is not discriminating, but I want to be a little bit specific. So now this is what I'll do. If I'm to do data dot, when I do data, sorry, first of all, let me do data. This is the original one with the NA. Is that okay? Good. Now, when I do data and do the slicing over here and pass in, for instance, sepal length CM, okay, I'll do a Control-C, Control-V. This is just grabbing that particular column for me. So when I run this, I have all the entries in that column. All right. And clearly I have 154 entries. The data type is a float and stuff like that. Okay. Alternatively, this is the original data set. I could have done data dots and the name of the column. So when I do data dot, I want to go into the data and grab that particular column. When I run this, I get the same thing. But then the issue here is, like I said, this data is worked on properly for us, so we don't seem to have any problems. Sometimes we can create our own problems. So when we create our own problems, we need to find our own solutions. And the problem we might create for ourselves is, let's say we have sepal length and there are some spaces in between. If I do data set dots, for instance, the original thing was like sepal length this way, CM, then I'm going to have a problem. This one is not going to make it work, okay? And let me just show you by actually using a typical, the proper example. So now let's go to the modified data set and let's do extra modification over here. So let me do a spacing between the sepal and the length cm. And also let me add another space over here. Okay, so now let me save this. And let me close this. So let me come back to this and now import the data once again. So let me come in here. Good. So I'm importing the data. I ran it. Everything looks good. Now, originally, there were no spaces over here. Now, but now, when I ran this, you can see that there are some gaps in the column names. Good. Now, over here, we are filling any. So this one, we don't have any problem with this one. But then when I come in here, yeah. So then when I come in here and I come in to do data, we have the gaps over here. When I do a dot, the sepal length, like I have it this way, it is not going to work. It is asking, well, there's an invalid syntax. Is that okay? If I'm to put this together and run it, it is still going to tell me that the data frame has no object attribute sepal length. So this one is a little bit problematic. But then if I'm to wrap this up in a string this way, then this one is actually the proper thing, which is, the original thing in there. So what is it saying? It says, okay, I don't need to bring the dots. Very good. So when I run it this way, this one is working. So it pretty much depends on the data set that you have, and how things have been structured. Is that okay? So we can go this way, or we can make sure that if we are rest assured that there's no spaces in between names in terms of the column names, then we can actually go with let me come back once again and make sure that everything, there are no spaces in here. But this, I'm doing this so that you know exactly what you might come across. Okay, so sometimes you may encounter some errors which may not be your fault, but then the way things have been structured. So now let me run this all again so that everything works perfectly. So currently you can see that when I run this, it tells me that, well, there's a problem over here. And that's simply because there's no particular key with this as I have specified over here. So the general rule of thumb is you only use the dots if you are sure that there are no spaces. But then if you are not too sure, you can just use this and you can go. Now, there's a time I was working on a data and I almost cried because, my brothers, this is what happened. What I encountered was, and this was data somebody gave me I was working with. Now, the person, and I don't think the person was also deliberate about this, but then these are some experiences I've had over the years, which I can share with you. Maybe you can also learn a thing or two from it. Now, what a person had done was, there was a space over here, which is definitely not going to be obvious. So there was a space after a particular column name. And over here, I've just given one space over here. Now I'll save this and we'll come back to this and we'll try running this. And we are going to have problems because it is now not looking like this, but then looking like this. So now let me go back. I'll save it with that space over there. And then I'll run this way. And now clearly you can see that we are having a problem over here. It tells us that there's no key like this. Meanwhile, the original data set, even if you are to look at it this way, you don't clearly see that there's a space over here. But like I said, I've done it, you've seen it, so definitely when I do this space, now this one is working. It is even more dangerous if you think, oh, based on what you see, like this, based on what you see, there's no space anywhere. So you can do a dot, the name of the column, and things are going to work. And here you encounter a problem, you look through. I spent about an hour. Then I had to actually think through it, and I went back to make sure that everything is exactly how I want it to look. So please, these are some things you may encounter working with data. So you make sure that your column, if I ask for your column names, even if you are going to spend about an hour on them to make sure that everything is right, you do that so that you don't have problems moving on. So let me just delete that space that I created out over there. So, okay. So I've deleted that, and then everything I believe will work now. So let me go back and once again run this. Okay, so now everything is working. So now we can grab this way. Now there's also an advantage of using the square brackets. So let me show you. So if I'm to do data and I use the square brackets, once again, I can pass in sepal length CM this way. Then I can pass in another one that I want to see. Okay, so maybe I can also, or I want to see the sepal width CM. So I'll bring this sepal with CM. But then we are going to run into an error, which we are going to fix later on. So now see, when I run this, we get a problem. And I'm showing you all these errors because these are things you will encounter on a daily. So it tells you that, well, there's a key error with this particular thing that you are trying to put in there. And the only problem is, okay, originally, this should come as a list, okay? So if there are multiple things that you want to pass and see, then you need to put this as a list inside of this bigger square bracket. So now when I do it this way, I don't seem to have any problem. So everything looks good. Now, the main thing that we are trying to learn over here is to fill the NA. And that's brought us about, a lot of things over here. So now let's go back to filling the NA, now that we have some knowledge over here. So now we have the NAs, the null values showing up over here. We want to fill them, but I want to be more specific. So let's say with this petal length CM, okay, I'm going to grab this. So this petal length CM, I want to do this dot fill NA. And what do I want to fill this by? I want to fill this by 50. So I'm saying that, okay, when I do, for instance, this, it's just going to give me everything under petal length CM, okay? When I do this, everything under petal length, but I have some NAs over here. And I'm saying that, okay, I want to do a filling of this, anything now value you see over here, put 50 over there. But then I need to reassign it back into this. And let me just do it this way. I need to reassign it back into that particular column. So I'm saying that the petal length, the data, petal length CM, grabbing this, I want to fill that with this particular 50 as I have over here. So now when I run this, everything is working perfectly. Now when I do a preview of my data, you see that that particular null over here is filled by 50. And indeed, if there are any other nulls over there, it is going to fill by the 50. Okay. Now let's do same for the petal width, because as it stands, petal width is still having nulls over here. So now if I'm to do a duplicate of this, and let me just copy this, Control C, Control V, and then Control V over here. So basically I'm saying that, okay, the original data set is data, but then I'm grabbing the petal width CM, that particular column, and I want to do a replacement by filling NA with, let's say, let me also use a number that's very different over here. So I'm saying that I want to fill all the null values in this particular column with 900. So now when I run this, and I'll come back to run my data frame back, clearly I see that all the nulls associated with petal width CM is now 900. And then all the null values associated with petal length CM is now 50. So that's just by way of being specific about it. Now, like I did indicate, we are filling with NAs, but then, we are filling the NAs, but then we can be a little bit scientific with our approach by actually using, how do you call it? The means and the medians and the modes and stuff like that. So now look at this. The original data set has now been modified. I'm having this over here. Okay, this is not what I want. So now let me just do a new import over here. So pd.read_CSV, and then I want the iris_modified.csv. Now, chances are if you are working on your data set, you are not going to come back and do the things I'm doing over and over again, okay? This is just to show you that, okay, this is what we can do. These are the other options, and this is how we go about them. So we have the now values over here because we are doing a new import of our data. Now, what I want to do is, for instance, let me grab the petal length, okay? Let me grab the petal length and do some few things over here. But then there's another method that we can use. We can say data.describe, okay? So this describe is going to give us a little bit more of the statistics, okay? So over here, we see that, okay, this one is giving us the count, the total number of instances. As far as the ID is concerned, is 150. As far as this one is concerned, is 150. So over here too, we can simply do the math, okay, and say that, okay, based on what we see, clearly, we have one missing over here. Over here, we can also say that, okay, based on what we see, we have 4 missing over here and stuff like that. And over here too, we get to see the mean in terms of the ID, in terms of the sepal length, this is the mean. In terms of the sepal width, this is the mean, okay? These are the averages. We get to see the standard deviations over here as well. Now the minimum value, and once again, this is also going to help us actually see outliers. So over here, we see that the minimum value we see is 4.3, and the maximum value we see for the sepal length is 7.9. Imagine the minimum value being 4.3 and the maximum value being 790 instead of 7.9. Then clearly something should just click. Okay, that's, well, we may have an issue over here. And these are the quartile ranges, the fourth quartile, the half of it, and also the third quartile stuff. Okay, so this one is looking good. Now, based on what we see over here, okay, I can say that, okay, I want to replace, for instance, all the now values in the sepal length column with their average or the mean. Now, look at this, the petal length CM. If you have to look at this, the petal length CM, the mean is 3.7, okay? The mean is 3.7. And with the petal width, the mean is 1.9. So clearly, their means are completely different. So I cannot just say, okay, because I'm replacing by means, I'm just picking one mean and just replacing it with all of them. No. Each and every mean is quite different. This one, you can see that the mean is very small, and this one, the mean is quite average, okay? So we can be more specific over here. And clearly, we can go about that this way. So what I'm going to do is, if I'm to do data, and once again, bring in petal length CM. Originally, this is what we have some of the now values over there. Now I can do a dot mean. So basically all that I'm saying is, okay, when I do a printing of this alone, just as I have over here, I'm getting all the values. The mean, I mean, the none is just like 0 or there's nothing over there. So I'm just saying that, okay, just get the mean or calculate the mean for me. Now, when I run this, that's exactly what I get. And it is 3.746. That's exactly what you have over 3.746, so and so. Okay. So over here, I can call this petal underscore length. Let me do it this way. So petal length underscore mean is going to be equal to this. So if petal length mean is equal to this, then what I can do is, once again, if I do a preview of my data set, this is what I want. I want to replace all the petal length CM with the mean that I've calculated over here. So what I'm going to do is, I'm going to grab this, put this in this, okay, like we did before. I want to grab that particular column and now do this once again, and now do a fill any. And this one, not just any arbitrary value, but then the calculation of the petal length CM over here. So now when I do this, it's now going to replace everything with the mean that is going to be calculated. So now when I run this, everything looks good. And then when I now do a preview of the data, clearly I can see that this was calculated. Okay, originally this was where the now values was going to show, but then it has now been populated with the 3 points, whatever mean that we saw. And we can also do same for the petal width CM. So now let me also quickly do that. Our time is almost up. So this is the petal width. Okay, so let me do PW for the petal width. And now let me just do Control C over here and Control V. So this is also calculating based on grabbing. This alone is going to grab that particular column. Dot mean is going to calculate the mean, and we are going to save it in the petal width over there. And let me also do the replacement over here. So once again, let me do a Control C of the particular column, and then I'll do the changes over here. And of course, I also have to change this and replace it with that particular calculation. So yes, I'm running too fast, but then systematically, everything should make sense to you. So once I run this, it says, okay, so I didn't run this cell, so let me run this. And now everything looks good. And now if I'm to run the data, now a lot of replacements are being done. Okay, so everywhere there's a null value, definitely the mean of that particular column is going to be calculated and fixed over there. So we are cutting down on null values. Now, if I'm to do data.info, we are still going to have some null values because those were not the only places. So for instance, sepal length, we had just one, and sepal width, we also have one, sorry, about 4 missing. So let's calculate those ones as well. So once again, let me just do a Control C of this. And let me just do this. And those are the sepals. So the sepal length, Control C, and let me do sepal length. And let me change the name over here. So let me call this SP. So sepal length, yes. Okay. And let me call this, you can use your own variable names, okay? So there's a sepal width, so SW. So we are calculating the means over here, and let's do the replacement over here as well. So once again, this one, Control C, Control V, Control V, and then we are going to replace it with this calculation that we have done over here. And then once again, I'll do this, and I'm going to replace it with this as I have over here. So once again, let's run everything. And now when I run this, and then I run the entire data set. Now everything has been replaced, okay? How do I know? Okay, now let's do a .info. And now we have 154 entries over, and everything is showing up as 154. So clearly everything has been replaced. Now, after the replacement, we can also now come and look at duplicates, how we can drop duplicate and stuff like that. So this is typically something I give. So please, when you go home or between now and Thursday, when we meet again, you can actually look at this. So look at an instance where we are going to use the median, and the median is definitely going to be, when I do data, okay, dot a particular column, where's the data dot a particular column, okay, like this. Okay, the dot mean will calculate the mean for me. Is that okay? So this is the mean. If you want the median, it's just dot median this way. And this is also going to calculate the median. If you want the mode, dot mode this way, this is going to calculate the mode for you. Okay, so the point I'm trying to make is create other data sets, okay? I mean, from the same data set, first one you replace with the mean, second one you do one with the median, other ones you do one with the mode, and see how your data works. Now, there's no right or wrong answer or right or wrong approach to some of these things. The most important thing is there should be a justification for whatever method or technique you decide to use, or whatever statistical inference you decide to use. The point is, the ideal thing to do is to actually, for instance, if there's a typical, let's say, your research work that you are doing, what you need to do is to, okay, if you are replacing and maybe the data set is too small, first of all, you can just drop duplicate, build a model with it, and see its performance. Then you go to another level of now replacing duplicates with, for instance, the mean. Then you build another model, look at the analysis and see which one performs better. Then you build another model where you replace the duplicate with the median. Build another model. So at the end of the day, you may have about 5 different models. One, you just drop duplicates. The other one, you replace with the mean. The other one, you replace with the median. The other one, and you see how the analysis of such is going to be. Now, remember, in this particular data set, I have some duplicates over here, okay? Now, when I do data, clearly everything has been filled, the NA, everything is looking jeje, okay. But then, the interesting thing is when I do data.duplicates, duplicates this way, and run this, okay, so over here we get something interesting. So it says data frame has no attributes duplicates, okay? But then it is giving us some help over here. It says, well, to remove duplicates, we can use this duplicated and drop duplicates. So I think the one I wanted was duplicated. So I'm asking a question. The data frame that I have in there are some values duplicated, and it is telling me that for the first instance, it is false. The second instance, it is false. But then the third one, it is true. Wow, how is he able to do that? Now, let's once again go back into our data sets, and this is a modified, okay? And let's look at something over here. Remember, the first one, it told us that it was false. Second one was false. Third one was false. I think it was a third one also that was. So now look at this. Now, when you say something is a duplicate, it can mean a lot of things, okay? But over here, the duplicate means the feedback. Over here, the duplicate basically means every single entry is the same, including the ID over here. Yes, you can have entries being the same, which may not be duplicate, but this one is very strange because look at this. We had IDs also repeating. And for instance, the one with ID 2, we have 4.93, 1.4, and here was now an Iris Etosa. Over here too, we had 2, ID 2, 4.9, 3, 1.4. So clearly this is a duplicate. All right. So over you see that on the third one, we see that it is true because the third one, as we see over here, is a duplicate of this first one as we see. So clearly it is able to figure it out and tell us, well, there are some duplicates in there. And the moment we see some of these things, we can say, oh, okay, then we can actually look at this. Now, looking at it this way may not even make sense in a way, because over here, the duplicate is just on the third row. That's what you see over here. But then if it is on the 70th row, then it is going to be truncated like this, and we are not going to see, okay? So then I can also chain this up with another method, okay? And let me just do, let me see, is it count values or values count? It is one of them. So let's do count values and see if this one works. Okay, so it says, okay. Let me see values count. I don't know if this one is going to work. Okay, so because this is not, and once again, let me explain this error. It says that this is a series, okay? And the series is not having this attributes. So some of the things we can do on data frames, we cannot do on series. That's basically what we are being told. But then the point is, we are using the duplicated to check. Now, if you want to drop duplicates, it's also very simple. Now I can do data dot drop underscore duplicates this way. And now let me just call this out over here. So now when I run this, now we don't seem to see a lot over here, but then trust me, the duplicates have been removed, because now when we check over here, we see that we have 150 rows by 6 columns. And now when we check row 1, row 2, the only thing we can see in terms of we verifying that, okay, something has dropped is because, you see, look at the indices we have over here. We have 0, 1. We jumped from 2 and then went to 3. So you could see that the first 2, which was a duplicate from this one, had been dropped. All right. And for this reason, we can confidently say that, okay, everything is good. Now, let me quickly talk about these last three things over here, because that's also going to help us.
Okay, Ken.
Yes, sir.
Sorry, I think maybe we can pause here so that we don't jam them too much with, so that we'll continue on Friday.
On Thursday.
Sorry, Thursday, sorry.
All right, sir.
So that we don't push too much.
Okay.
Otherwise, people will just listen to you and then that is it.
Okay.
So we can pause here and then we continue on Thursday.
Sure.
But what I want us to do is let's all go through the Kaggle data set. And then I want all biomedical students on the platform individually, it's all joint. Every individual should identify a data set that he or she is interested in working on, whether it is a cancer, whether it is a heart, whatever. So each of you should identify a problem or data set that you want to play with. Not more than one person should not take two, just one data set. And then what we have done so far in terms of the pandas to do the import the data and then check the data type and all those things. And then check whether they are duplicate and whether there is null. And I want you to go through all that process. And then when we meet, we will continue from where, so that you'll be able to follow and do something for yourself or for yourselves. Are we okay on that? So that is biomedical. Material science also, and there are also data set in there. So I want every department to go through the data set and then find out which data set they will be interested in working on. Once you pick that one, then we will continue through that process all the way through, so that when you are doing something, when we start with the model development, you would have processed your own data, and then you continue with that process one after the other. Okay, so the floor is open. If anybody has any question, you can ask that question. If anybody has any question, you can ask the question. I presume there are no questions. So we will share what we have done on the platform, the video on the platform for you, so that you can follow. And please, this is not a classroom work where if you are interested, you want to pick up the skill, this is what we do. So I want everybody to try your hands on whatever you are being taught. Otherwise, then we are wasting our time. Then we just have to stop. Okay, so we meet on Thursday.
All right, sir. Okay, so goodbye, everyone.
Yeah, so Ken, when they come, we'll just do random calling so that they should share with us what they did.
All right, sir.
Okay.
Okay.